Solar flare. A solar flare is a sudden and intense release of energy from the sun's surface. It is characterized by a burst of electromagnetic radiation across a wide range of wavelengths, from radio waves to X-rays. Solar flares are usually associated with the formation and eruption of sunspots, which are areas of intense magnetic activity on the sun. During a solar flare, a tremendous amount of energy is released in the form of electromagnetic radiation, particles, and high-energy plasma. The energy released during a solar to millions of hydrogen bombs exploding simultaneously. This energy released in the form of X-rays and ultraviolet radiation. Solar flares can have various effects on Earth and its surrounding space environment. The high-energy radiation emitted during a flare can cause radio blackouts, communications, and interfere with the operation of electrical power grids. Powerful solar flares can even pose a risk to astronauts and satellites in space. Solar flares are classified into different categories based on their X-ray. The classification system used is called the GOES X-ray flare classification and range A class, weakest, to X class, strongest. Within each class, there is a scale from 1 to 9, higher numbers indicating greater intensity. For example, an X2 as intense as an X1 flare. It is worth noting that while solar flares can have disruptive effects on Earth, our planet's atmosphere and magnetic field provide some level of protection. The Earth's magnetic field most of the charged particles emitted during a flare, preventing them from directly reaching the surface. However, strong flares can still affect our infrastructure and satellite. Scientists monitor solar flares closely using various space-based telescopes. By studying solar flares, researchers can gain insights into the sun's activity, its impact on space weather, and its long-term effects on Earth's climate.